to that. So the first question in this, they're saying, you can see every question will be challenging question only. It's not that much easy. So you should go through that and you have to make it. So the question number 1, it's speaking about, you all can notice it. On undergoing complete combustion in an adequate supply of oxygen, an organic compound produces only carbon dioxide and water vapor as the products. So complete combustion they are saying. So you all people knows an adequate supply of oxygen, an organic compound produces only carbon dioxide and water vapor as the products. So it is a what, everybody? Saturated or unsaturated? Anyone?
Saturated.
Yes, please. Saturated. So saturated means what? Anybody? Yes?
Alkane.
Yes. So open your classwork and you can see that while we are testing the flames, blue flame and as well as yellow flame, after writing the alkane, that is what CH4 burning reaction, immediately down you have written some other thing also. Can you verify it, anybody? Alcohols and as well as aldehydes also. Am I right or wrong? Verify in your classworks and let me know. Have you written, everyone? Check it, everybody. Harish, all of you has to do it. Verify your classworks. So while I'm teaching the burning concepts, you can notice it, everybody. So even if you have written it, definitely you might be have. So everybody has to return. So there is a burning concept which is producing the yellow flame. You can see that yellow flame and blue flame. So after that, there is a concept before that, combustion. All of you check it in. Combustion we have written or not? All of you? Ma verify ma. Combustion you have written or not?
Yes, sir.
Yes. So combustion, you can see that methane burning we have written CH4 plus O2 gives you CO2 plus H2O. Next, alcohols, OL correct. Alcohols, if you have taken, I think ethanol or else methanol you can take. So CH3, CH2OH gives you, react with oxygen, gives you also CO2 plus H2O plus heat. So like same way, aldehyde, can you tell me one of the example of aldehyde? Anybody? One example for aldehyde. Yes, please. Aldehyde means what? What is the functional group? Actually, nobody knows. Aldehyde means one functional group I wanted. Anybody? Aldehyde example, guys.
The propanol.
Yes. So aldehyde means what first actually? It is C double bond O single bond H. Am I right, everybody? Alcohols means OH group. So alkanes means we all knows that it will start from the methane, CH4. So now you all can notice it, alcohols, alkanes, alkanes and alcohols and aldehydes. So alcohols and aldehydes, they are actually the derivatives of alkanes. Just we are replacing the functional groups. So under the complete supply of oxygen, aldehydes also, your book if you have taken the first example of aldehyde, they have given propanol. Am I right, everyone? All of you? Yes, please. Tell me, guys. Yeah, propanol, what is the formula will come? So propane we are replacing with the oxygen. So CH3, CH2, CHO. Am I right, Amma? This is what is the propanol. So propanol will undergoes oxidation reaction. Right, everybody, equation. Propanol will undergoes oxidation reaction. That is what combustion. Then it will produce us again. So same actually, it will react with the oxygen. It will also will produce us carbon dioxide plus water. So everybody check it here. So produces only carbon dioxide and water vapor as the products. So now what is the answer? Based upon this information, which of the following homologous series could the compound belongs to? Anybody? What is the answer? Who will produce, guys?
Option 4.
Yeah, alkanes also producing. Alcohols, already I have taught you in the classwork. Classwork combustion time. Have you written or not? Verify it, everybody. Are you clear? So please remember, whatever it is, if you have taken all the substances, the derivatives of all the substances, alkanes, alcohols, aldehydes, everything they will undergo combustion reaction and they will produce carbon dioxide plus water vapor. So what is the correct answer, everybody? Yes,
Option 4.
please. Option P, Q, and R. So write it, everybody. It's very, very important. So propanol, CH3, even propanol we can write C3H8O. So propanol undergoes oxidation reaction with oxygen. It will produce carbon dioxide plus water. Make it, everybody. Anything doubt, you can ask me. Okay, guys? All of you? Yes, please. So even your book you can open 69th page, number 69, you all can see is that 3 reactions will be there regarding the combustion. One is carbon is burning, next one is alkane is burning, next one is alcohol, OH is burning. Am I right, everybody? Verify it, guys. It's a propanol. Is it right? CH3, CH2, OH. Correct, Amma? Yes? So now you add aldehydes also. So aldehydes also undergoes combustion reaction and they will make that is what. Make it, everybody. Clear? Hurry.
Sir,
Yeah.
propanol C3H6. Sir.
C3. What hurry?
Sir, you wrote R3H8O, sir. That is C.
3 plus 2. Yeah, 6. C3H6O. Okay. Is it okay, Hurry?
Yes, sir.
Yeah. Any doubt? Anybody can ask. Are you clear? First question. So next. A compound with which of the following functional groups is most likely to cause the decomposition of baking soda to produce carbon dioxide? All of you observe very carefully. The question is very important. A compound with which of the following functional groups is most likely to cause the decomposition of baking soda to produce carbon dioxide? You all know this is the concept related to chapter number 2. So if you are having NSAID, that's the reason I'm saying. Chapter number 2, baking soda decomposition reaction we have. First of all, you tell me, OH means what is this actually? OH means what is the functional group? Everybody. Alcohol. Yes. Next one. Everybody has to involve in the class and you have to say. Next one. C double bond OH. Just now I told you. What is this, everybody?
Aldehydes.
Aldehydes. C double bond O. What is this one?
Ketone.
Next one. What is this one?
Carboxylic acid.
Carboxylic acid. Now, I will say you chapter number 2. All of you open. We all notice that baking soda, if you add to the cakes, the taste is not, it will be bad taste. If you want to make it to good taste and as well as very soft and fluffy, we have to add some acid. Anybody can remember that acid? Chapter number 2. Anyone? Tartaric acid. Tartaric acid. Or I can add it citric acid. Am I right, everybody? So citric acid or tartaric acid. What is the functional group? Anybody?
Carboxylic.
Over. Answer is clear, everybody. So how smart the questions will be? This is what it is. So that is the reason I'm saying. So where it will comes? Page number open, everybody. Acid, bases and salts. Page number 31. Page 31. All of you check it. What is that? Uses of baking soda. For making baking powder, which is a mixture of baking soda, sodium hydrogen carbonate, and a mild edible acid, such as, what is that mild edible acid, everybody?
Tartaric
acid.
Tartaric acid. Tartaric acid is a what? Who is the functional group?
carboxylic
Carboxylic acid. That's all. I hope everybody understand. Clear? Do it. Next. 1 mole of ethene. This is last class I taught you, offline class. 1 mole of ethene and 1 mole of ethane are separately made to completely undergo addition reaction to form the respective saturated compound. Last class only I taught you. Ethene, that is what? Alkene. Alkene to alkyne. Sorry, alkane. We need 1 mole of hydrogen. If it is alkyne to alkane, we need how many moles of oxygen? Everybody? 2 moles of oxygen. Sorry, 2 moles of hydrogen. I told you now. Hydrogenation of oils. All of you remember, everybody? Last offline class I explained you. Am I right, Amma?
Yes, sir.
Yes or no? The same thing they are asking now here. So 2 moles of oxygen, 1 mole of oxygen. Sorry, hydrogen it is. So you all can see that. Alkene to alkyne. Alkene to alkane. 1 mole of hydrogen. Alkyne to alkane. We need 2 moles of hydrogen. Now the question is, all of you, which of the following will be different for the two reactions they are asking? So what is the different? Anybody? Finally, ultimately, what is the product? Anybody can tell. What is the product we are getting ultimately? Alkanes only. Am I right? Esra? Alkanes, alkanes. Now, which of the following will be different for the two reactions they are asking? The number of moles of the saturated compound form. See that. The moles of saturated compound will get the same. The number of moles of the hydrogen consumed, which is changing. Anybody? Here 1 mole of hydrogen, here 2 moles of hydrogen, but finally product is same amount of alkane, the same will come. So what will happen, anybody? You all can write it if you want. Ethene, what is the formula of ethene? Ethene formula, tell me, Amma. C2,
H4.
C2H4 reacting with the 1 mole of hydrogen under the catalyst of nickel or palladium. So we'll get C2H, H6. Am I right, Amma? Correct? Now, ethine. What is ethine? C2H2 undergoes addition reaction. That is what? Hydrogenation of oils. So under the catalyst of nickel, we'll get first C2H4. And again undergoes addition reaction with hydrogen, we'll get C2H6. So see that, everybody. Is there number of moles of hydrogen? Sorry, alkane is remains same or not? Everybody? Yes or no? Please respond. So same. So first statement is not. Second one you see here only 1 mole of hydrogen, but here 1 and 2, 2 moles of hydrogen. So what is the only answer? Anybody? Which of the following will be different? They are asking. Which is different? Consumption of hydrogen. Here 1 mole of hydrogen is consumed. Here 2 moles of hydrogen is consumed. That is the difference. Okay, guys. Understand, Mr. Nimesh? Google? Do it, everybody. Anything doubt you can ask. Okay?
Yes.
Yeah. Clear, guys? Any doubt? Anybody can ask. Are you okay, everybody? Understand? All of you?
Yes, sir.
Yes. See, that is the reason I'm saying, unless we have a complete idea, it is not possible to solve the questions. So every concept is very important only. We cannot leave any question. Write it, everyone. We'll proceed. Completed? Everybody? Understand, Amma? All of you? Okay. Right, next question. This is very important, assertion reason. You can notice it. Two statements are given below, one labeled assertion and the other labeled reason. Read the statements carefully and choose the option that correctly describes the statement A and R. You all try to answer, then it will be good. Simply I am saying what is that. Next question regarding same saturated fats. Vegetable oils are healthier than animal fats. Book you can notice it. So here they mentioned it. Animal fats generally contains saturated fats. I told you even. So animal fats generally contain saturated fats and which are said to be harmful for the health. Oil containing unsaturated fatty acids should be chosen for cooking. So who will be containing unsaturated? The vegetable oils. Vegetable oils are healthy because they contain unsaturated fats. But if you have taken the animal fats, they contain the saturated fats. So which is good for health, everybody? Saturated or unsaturated? Everyone?
Unsaturated.
And animal fats contains saturated fats and vegetable oils contains unsaturated. So unsaturated means either alkenes or alkynes. Understand? So these are good for health. So it is the true. Next, vegetable oils generally have long unsaturated carbon chains, they are saying, while animal fats have saturated carbon chains. Is it true or not, all of you? Yes, please. Why vegetable oils are good? Because they contains unsaturated fats. And why animals fats are not healthier? Because they contains unsaturated carbon chains. So what is the correct answer? Anybody? Yes, please. Vegetable oils are healthier. Why? Because they contains unsaturated carbon chains. Animal fats are harmful. Why? They contain saturated fats. So what is the correct answer? Anybody?
Option 1.
Option A. Understand? So both assertion and reason are true and R is the correct explanation of assertion. That is what you have to write it. Everybody make it clear? Mr. Rohit, Harish, understand? Abhirami? Yeah. So next question. This is one of the most important question. So everybody has to try. I'm expecting everybody is there in the class and you have to try, those who are there. So please show interest and make it. So now, alkanes are saturated compounds. Alkanes are saturated compounds of carbon and hydrogen that can be represented by the general formula CnH2n plus 2. We all people knows that. What is the alkane general formula? Alkanes general formula CnH2n plus 2. Next, alkenes. Alkene general formula what am? CnH2n. Alkynes. Alkyne general formula CnH2n minus 2. Now, where N is the number of carbon atoms, an example of such a compound is ethane. What is the ethane formula? Verify it, everybody. Ethane means second compound. C2H6. Am I right, everyone? Ethane. Now they are asking. Maya has a compound of carbon and hydrogen whose formula is C3H4. C3H4. Basically, if it is the alkane, next compound what should come? C3H8 should come. But now here we have C3H4. So means it is a what? Alkena, alkena, alkyne. Anybody?
Alkyne.
Alkyne. C3H4. So if it is, let me take C3H8. If it is C3H6, it is alkene. It is C3H4, guys. So it is a what? Alkyne, alkene, alkene. Everybody. It is. What it is? Alkyne. Understanding? Alkyne. So alkyne means what? Saturated or unsaturated? Everybody.
Unsaturated.
Unsaturated. That is the first thing. Next. What is true about the type of a flame this compound will give on combustion? What is the flame it will give? Complete combustion or incomplete combustion? They will give what? Sooty flame or blue flame? Everybody.
So,
They will give what? Unsaturated hydrocarbons. They will give what, guys? Sooty flame or white flame? Everybody. So blue flame or a sooty flame? Unsaturated carbon compounds will give a yellow flame with a lot of black smoke. That is what we used to call it as a, what is that call it as? Sooty flame. Okay, all of you. So that is only the concept. So what is true about the type of a flame this compound will give? It is a smoky flame. That is what is a book. It's a black smoke, or you can see the sooty deposit of the metal plate. So yellow flame with a lot of black smoke. That is the answer. Yellow flame with a lot of black smoke. Next, draw all the possible straight chain structures of this compound. Possible straight chain they are asking, guys. So can you draw? Anybody? Draw all the possible straight chain structures of these compounds. So straight chain they are asking. So let us see, everybody. So what is that actually? Number of carbons. Anybody can tell? Number of carbons. All of you. C3H4. So first make everybody 3 compounds, 3 carbons in a straight chain. Straight chain they are asking. So actually, this is very complicated one. So unless you have a complete idea, it is not possible to make it also. So all of you do it fast, all of you. So it's isomers. Isomers of C3H4. Do it fast, everybody. So it is a saturated, unsaturated hydrocarbon. So C3H4, if you notice it, isomers, all of you, then you will get straight chain. Actually, we will get a 3. So 3 carbons means closed chain also will possible. Am I right or wrong, Amma? Everybody? Yes or no? Is there anybody in meeting or shall I wind up the class? No issues. I also want to sleep. So they are asking only what, all of you, straight chain alone. So even for the 3 compounds, I can form what? Can I form the closed structure also? I can form it or not? All of you. Yes, I can form. So how I can form, you can see, but it is not required. But why I am saying you, closed structures also they will ask you. So now C3H4. So H4 means only 4 hydrogens we have. So we have to balance it. So how to balance it? Let us see. I'll make one double bond. Don't think it is always, sir, it is alkyne, correct, sir, triple bond has to come. Closed structure means we want isomers. Isomers means it is not that rule it is following. Now you can see, first carbon, 2 bonds are over, I will put 2 hydrogens. And second carbon, 3 bonds are over, 1 hydrogen. Third carbon, 3 bonds are over, 1 hydrogen. That's all. This is what we used to call it as a cyclopropene. Propene. Understanding, everybody? Cyclopropene. But here they are not asking this one. What they are asking, everybody? Anybody can tell? What they are asking, guys? They are asking what? Straight chain. So first straight chain, what we know very well. It is a what actually? Unsaturated alkena, alkyna. Everybody. It is alkyne. Alkyne means what? At least how many triple bonds?
1 triple.
One triple bond. So I am making 1 triple bond. All of you observe. So 3 carbons we have. So anywhere you can make 1 triple bond. So I am making 1 triple bond and remaining hydrogens I am balancing. So 3 bonds are over. First carbon, how many hydrogens? 1 hydrogen. Second carbon, 3 plus 1, 4 over. And last carbon, remaining 3 hydrogens. Any problem for anybody? Are you clear, everyone? Yes, please respond. All of you?
Yes, sir.
Yes.
Sir.
Now, you all can see that, everybody. Any doubt? Clear? So, the name of this compound, if you have checked it, actually the structure also you can draw. So, basically, the name of this compound is actually, if you have taken, where is the triple bond? You can see that. It's a probe. 3 carbons are there. 3 means what we used to call? Anybody? 3 means what we used to call? Probe. Am I right or wrong? And wherever triple bond is coming, it has to get the lowest possible number. So probe 1 wine. That is the name of this compound. Probe 1 wine. That is the name of this compound. One straight chain over. Next, sir, second straight chain. They are asking all the possible. So how many? Two possibilities will come. So second one, C double bond, C double bond, C. So that is what is the second possibility. So you can see that second carbon already 4 bonds are over. First carbon 2 hydrogens, last carbon 2 hydrogens. Name of this one is propa 1,2 diene. Because why sir di? How many double bonds are there? How many double bonds are there? Everybody? How many double bonds are there, ma? 2 double bonds. That is why
Two
it is
double bond.
diene. Propa 1,2 diene. I am giving the carbon numbers 1, 2, 3. Propa 1,2 diene. This is what is the possible isomers. Unless you have drawn the isomers of every compound, you can check it at least 5. That is the reason I will say for every compound homologous series, you have to draw minimum 5 compounds. If not, it is not possible to make it. That much it is tough. So what is the 3? Actually 3 will form, guys. What is the 3? Cyclopropane, propane 1 wine, propa 1,2 diene. So in that they're asking only straight chain. So straight chain means this 2 will come. Branched chain, sorry, cyclic means this alone. So if exam they'll ask you cyclic, you have to make this one. See, sir, how sir? Is there any possibility, sir? I'm saying you. Listen, everybody. Don't worry about anything in exam. Given formula, you arrange first carbons. For example, C3 given. So C3 given. So C3 means only triangular structure will form. You balance it. Now only 4 hydrogens is given. You randomly put 4 hydrogens. Let me take here 1 hydrogen, here 1 hydrogen, here 1 hydrogen. Now, still one more hydrogen is there. Am I right or wrong? C3H4. Is it right, everybody? So one more hydrogen is there. So what I will do? I will put somewhere. Here itself I will put. Now, or you want, you can put here. No problem. Sir, don't again, sir, only here you are putting, sir. You can take here also. So I will take this carbon 2 hydrogen. So check it, everybody. This carbon 4 bonds are over. 1, 2, 3, 4. This carbon 1, 2, 3. This carbon also 1, 2, 3. So I'll put somewhere double bond. So we all know. Now you verify. This carbon 1 plus 2, 3 plus 1, 4. This carbon 1 plus 2, 2 plus 2, 4. This carbon 2 plus 2, 4. Over. So like that you have to draw the structure. Are you understanding? Number of bonds alone you have to verify. For carbon, how many bonds will come? Everybody? For carbon, 4 bonds has to satisfy. If you remember that, that is enough for us to solve. Okay, everybody? So please do it. It's very important. Names also learn. Isomers is going to be definitely is not easy at all in the board exam. Okay. So like this isomers only last year also there is a question. You can verify that. Okay. Board paper. So isomers is extremely important always. That's the reason I say. Next. Again. So the concept while I'm teaching this one, addition reaction, after we studied substitution reaction. So the substitution reaction, here we are adding only chlorine. But I have taught you there is another test. What is the test we can say? Anybody? What is the test I have taught you? There is a test which will use to identify the unsaturated hydrocarbons. Saturated, they won't react, but unsaturated, they will show displacement. They will decolorize some substance. Anybody?
Bromine.
Bromine test. Understanding? Bromine solution. Do you all remember, everyone? That is what is the next question. You can notice it. Bromine water is a reddish solution of a bromine, Br2, in water when shaken with an unsaturated hydrocarbon. Are they alkyna, we don't know. Then the red color of the bromine water disappears because the bromine is used up in an addition reaction. Am I right or wrong? All of you? Addition reaction. Is it right? Clear? Now, here, addition, that is what substitution or addition. Oh, sorry, addition reaction only. Sorry, ma. Addition reaction. So now, if you have noticed it, who is this? Cohelia. Yeah, Cohelia has 3 test tubes containing hexane, hexene and hexane respectively. Which of three compounds can he identify using the bromine water test? Give a reason for your answer. Which he can identify? Anybody? He can identify what? Hexana, hexena, hexina. Anyone?
Hexene.
He can identify only hexane. Why he can identify hexane? Anyone? It is a
It's
what?
saturated.
Yes,
Does
it
not
is.
show any
It will
changes in
not decolorize. It will not decolorize the what? Bromine water. Understanding? So remaining hexene and hexane, we cannot identify which test tube, but both are, we can say it is what? Together we can say what? Unsaturated. Am I understand? Do you all understand, everybody? Both are unsaturated, but we cannot say, understanding everybody? Unsaturated. So we cannot say them which is exactly hexene and hexane. That is why we will say only hexane is possible, as it is a saturated hydrocarbon. Saturated hydrocarbon, it is unreactive with the bromine water. So it is addition reaction. Instead of hydrogen, we can use another substances. What is that, everybody? Yes, please. Halogens like chlorine and bromine. Am I right, guys? Everybody? Yes, please. All of you? That is okay. Next. Okay. So before question, I want to show you the answer also. Question number 5. So there will be answer, but there is no names. But why I want to teach you is you should know it. You can notice it. So possible isomers. Sir, here they have given double bond first, single bond is not a problem. So what is this? This one, first one. 1, 2, 3. So first, prop 1 in, Y in. Next here what? Propa 1, 2. So both carbons having double bond. 1, 2 diene. So this is what? If it is cyclic, you have to draw cyclic. Okay, guys? All of you understand? Yes? Everybody? So that is what? Next, you can notice it. Next question. A carbon compound of molecular formula C5H10O contains a ketone functional group. So directly they are saying ketone. So draw the structure of 3 isomers of this compound having a ketone group. I told you now, every functional group, minimum you have to draw the isomers. Minimum you have to draw five next compounds I told you. So try to draw all the isomers. Anybody? One important point you should talk about the ketone. What is that, anybody? Always between what? C double bond O, always present between what?
Alkyl.
Understand, Amma? Between two carbons, it is not supposed to be the last carbon. Am I right or wrong? That is the only point you should remember about the ketone. So now try to draw. So C5 they are giving. So C5 means I will draw here. So 5 compounds I will make it. Meeting is going to end, join back. So 5 carbons you draw first, everybody. 5 carbons. Somewhere you put double bond O. I am first putting here double bond O. So between 2 carbons, ketone. Balance the hydrogens. This one, how many hydrogens will come? How many hydrogens will come first carbon? Speak loudly. CH3, second carbon, CH2, third carbon, CH2, fourth carbon.